Hello, good morning students. I am Dr. Sunita Tandon from RR College Alwar. Today I am going to deliver lecture number 2 of special paper of physical, that is chemical dynamics. This chapter is about atmospheric reactions and general structure of atmosphere. We have studied in the environmental chemistry in quite detail. So here and we have also studied the NOx and COx cycles there. But here we are going in chemical and we are going to stress on the dynamics of such reactions, such cycles. NOx cycles I have delivered you on yesterday, that is on 10th of February, 10th of December. Now I am going to start CLO cycle on 11th of February 1922. At present, a major public concern in the depletion of the ozone layer by photodissociation of halomethanes, which are artificially produced substances like CFCl2, Freon 11, and CF2Cl2. This is Freon 11. One is CFCl3 Freon 11, CF2Cl2, this is Freon 12, which we have studied in earlier classes. What are freons? As well as naturally occurring substances like carbon tetrachloride CCl4 and also artificially produced haloalkanes. These materials are inactive to radiations occurring in the troposphere and are therefore transported into the stratosphere, where they are photolyzed according to the reaction. First we take the reaction of CCl2F2. Okay? It absorbs one quantum of radiation of wavelength between 180 nanometer to 220 nanometer, and one chlorine atom as a free radical is removed, and we got CF2Cl and Cl free radicals. Or they react with electronically excited oxygen atom, that is odd oxygen 1 in the state 1D, to yield chlorine oxide, या CLOX. Just see the equation. CCl2F2, it combines with oxygen atom in the state first T. This is the excited state of oxygen, and it results in formation of CLO and CF2Cl. Oxygen combined with one of haloalkane, a halo particle chlorine, and form CLO. These products then participate in catalytic cycle analogues to the HOX and NOx cycles. क्या करेंगे अब ये? These products which are from CF2Cl, CLO, etc., then they participate in catalytic cycles analog of HOX and NOx cycle, whose not effective in the removal of ozone and oxygen atom. ठीक है? जो HOX और NOx साइकिल्स के अंदर पार्टिसिपेट करते हैं, ये CLO जो यहाँ पर हमने बनाया ऊपर की रिएक्शन में, ये इस रिएक्शन में पार्टिसिपेट करता है, और उसका नेट रीजन उसका नेट इफेक्ट क्या होता है? रिमूवल ऑफ ओजोन एंड ऑक्सीजन एटम. So we can see that in next equation, Cl combined with ozone to form CLO and oxygen. This chlorine comes from the reaction where Cl2F2 combines with oxygen in excited state to form CF2Cl plus CLO. This Cl, ठीक है, combines with ozone to form CLO and oxygen. This CLO again combines with oxygen to form Cl and oxygen molecule. So अगर we add the net reaction, Cl cancels with Cl, CLO cancels with CLO, and net reaction is oxygen active oxygen, which is electronically excited, and in the 1D state odd atom oxygen combines with oxygen to form combines with ozone to form two molecules of oxygen. The major removal process for Cl atom in reaction with methane to form HCl C is only slowly attacked by hydroxyl radicals, allowing transport of HCl to the troposphere, where it is removed by rain via the following reactions. Cl free radical combines with CH4 to form HCl and CH3 free radical. This HCl reacts with OH free radical to form water and Cl. यही हमने आपको बोला है कि द मेजर रिमूवल प्रोसेस फॉर क्लोरीन एटम, जो क्लोरीन एटम बन गया उसका रिमूवल जो है प्रोसेस क्या है, इज रिएक्शन विद मीथेन टू फॉर्म HCl एंड C. सो जो फ्री रेडिकल बना इट रिएक्ट्स विद मीथेन. नेक्स्ट, एट लोअर एल्टीट्यूड कम हाइट पर द CLOx cycle can link with HOx cycle. At lower altitude, CLO cycle which we are studying combines with the HOx cycle in the following manner, which we will study later on. HOx cycle. OH combines with ozone to form HO2 plus oxygen. Chlorine combines with ozone to form CLO plus oxygen. The first two reactions, HO2 and CLO, they then combine in third reaction to form HOCl plus oxygen. And the last step, HOCl absorbs light and is converted into OH and Cl. If we add all the four reactions, we get the net result, 2 ozone molecules, they will give 3 oxygen. Rapid reaction of CLO with nitric oxide is an important reaction which links the NOx to the CLOx cycle. NOx cycle we have studied yesterday, and today we are studying CLOx cycle. So the net removal of CLO with nitric oxide is an important reaction which links the NOx to the CLOx cycles. We want to say that all these cycles are interconnected. They are not independent entity. One affects the other. One's reactant can be reactant of the other also. So CLO react with NO to form Cl plus NO2. Next point है, once initiated the longer catalytic cycle that results in ozone destruction involving NOx and CLOx radical occurs by the following chain of reactions. Cl combines with ozone to form CLO and oxygen. Nitric oxide combines with ozone to form NO2 and O2. And the reactant of products of this first and two reaction, CLO and NO2, they combine to form CLO-NO2. This addition reaction of CLO-NO2, product of CLO-NO2 combines with, absorbs light and is converted into NO3 and CLO. Then this NO3 absorbs light and is converted into NO and oxygen. And the net reaction of all these reactions is again 2 ozone converting into 3 oxygen. We want to say that all these reactions, जितने भी CLOx और NOx के रिजल्ट हैं, they lead to the depletion of ozone in the atmosphere. All ozone is converted into oxygen. Taking account of all these reactions in a model calculations based on the available rate data for such reactions indicate that the continued release of halomethane could cause eventually about 6 to 8% depletion at ozone in the ozone layer. The reactions which we have studied up till now, NOx reactions, reaction of NO, reaction of HCl with ozone, reaction of chlorine with ozone, these all reactions, when taken into account, all these reactions in model calculations, they are based on the available rate data. Such reactions indicate that continued release of halomethane could eventually about cause eventually 6 to 8% depletion of the ozone in the ozone layer. This is the reason why ozone is depleted in the environment, and this is hazardous because ozone acts as a barrier. It acts as a umbrella to protect us and earth from harmful ultraviolet radiations of the sun. So here we studied CLOx cycle, and tomorrow we will study the hydrogen and oxygen cycle of the hydrogen plus oxygen reaction of the atmosphere. Thank you.